Lesson 38, writing quadratic equations from roots. In other words, if you know what the roots are, you can write a quadratic equation from it. So we're just going to go straight to an example. So if the roots are -4 and 7, we want to write the equation. Basically, we are going backwards. So x equals -4 or x equals 7. Then we need to get 0 on one side because that's the definition of a root is a 0. So we add 4, so x plus 4 equals 0, or x minus 7 equals 0. Since these are the two zeros, we multiply those together and set it equal to 0. And then we FOIL our plan. We get x squared minus 3x minus 28 equals 0. And there's the quadratic function written from the roots. Now, here's an example where it's not quite as easy. It says write 3 equations whose roots are 5 and 2. So we can write the first one, just like we did up here. We say x equals 5 or x equals 2. Then we get 0 on one side. X minus 5 equals 0 or x minus 2 equals 0. Multiply those two together to get x squared minus 7x plus 10 equals 0. And then we could take this equation and multiply it by anything. So for instance, if I take this and times by -1, so I have negative x squared plus 7x minus 10 equals 0. That's a different equation than this one, but it's the same quadratic function. Or I could times by 2 to get 2x squared minus 14x plus 20 equals 0. So this is a different equation, same quadratic function though. So it will have the same roots. Now, what about if you want a quadratic and you only get one root? So write a quadratic with root 8. We know that a quadratic has to have 2 roots. So maybe this is a root 8 with multiplicity of 2. X equals 8. So x minus 8 equals 0. To make it quadratic, we just square it. So we have x squared minus 16x plus 64 equals 0, and there's our quadratic with root 8. Yes?
When it says root 8, it doesn't necessarily mean that 8 is the only root, does it? Because could you do x minus 8 times x plus 4 or something like that? Still, one of the roots would still be 8.
Oh.
But
in this particular example, so I didn't write it very clearly, but it is the only root. Yeah. And then you can have complex numbers. So an example using complex numbers that you can look at. So we want an equation, a quadratic equation with roots 6 plus 4i and 6 minus 4i. So we just do the same thing that we've been doing. We set x equal to each of those roots. And then we get 0 on one side. So we have x minus 6 equals 4i. And 4i is the square root of -16. And then we have x minus 6 equals negative root -16. So if x minus 6 both equals this, then we can just say, well, x minus 6 squared just equals negative 16. So when we square both sides, this negative will then become positive. So it's x minus 6 squared equals negative 16. Then we can multiply out and add 16 to both sides. And there's a quadratic that would give those. Those roots. Okay, so there is one more that's a little bit harder, and I'm going to turn the page. Are you guys all caught up?
Yeah.
Anyone need a few more seconds?
I think we do.
Okay. This is with a word problem. So you have a train tunnel. It is 35 feet high and 60 feet wide. Derive a quadratic equation to approximate that curve.
35 feet high.
Oh, no, you want it higher. Yeah, trains higher.
Oh, wait, train.
So in other words, we need a quadratic equation. We want to approximate the curve. So if you think about a tunnel on, we'll just think of the x-axis, and if it's 60 feet wide, we could put the curve right on, so it goes through 0, 0, and 60, 0. So those would be like our x-intercepts, which are our zeros. And then the vertex at the highest point would be right in the middle, so 30, 35. And now we need to write the equation y equals a, parentheses x minus h, end parentheses and square it, plus k. Now h and k are your vertex, the highest point. And then you would have to plug in your x and y of one of your points. So I'm just going to put this in really quick. Minus 30 quantity squared plus 35. Now I need to find a. So I'm going to use the point 0, 0 just because it's a super easy point to use. So 0 equals a times negative 30 squared plus 35. So I need to subtract 35 from both sides. Negative 35 equals 900a. Then I'm going to divide both sides by 900, and a is approximately negative 0 or 389 10,000ths. So my equation would be y equals negative 389 10,000ths, parentheses, x minus 30 quantity squared, plus 35, and I'm going to leave it like that because I don't want to mess up when I'm trying to simplify. So I just leave it like that, and there's my quadratic equation that approximates the curve through the tunnel. Okay, that's the end of lesson 83.